So this is a projectile motion question. And we've got two balls falling. At first it was which ball will hit the ground at the first, one ball is falling, the other one is traveling at 25 meters per second horizontal. Of course it's going to eventually fall as well. And the answer is that they're both going to hit the ground at the same time. So our first question that we're going to be trying to answer now is, how long will it take for each ball to hit the ground? Both at the same time, that's fine. So let's, if they're both going to hit the ground at the same time, the best thing to do is just to look at the one on the left and say, well, how long will that take to hit the ground? Now we're going to use our Suvat equations here. So the one that I'm going to use, I think, is going to be, let me just write it out and I will know. I think it's going to be S equals UT plus half AT squared. If I write the word Suvat out, and I can see what do I have. Well, the distance, displacement, that it's going to be traveling vertically is 5 meters. The initial velocity would be 0, because I'm not throwing it downwards. It's not going to have a starting velocity. It's just going to be traveling from rest. The final velocity, I don't know. And the questions don't ask me to find out either. The acceleration I know is going to be 9.81, because that is the acceleration due to gravity. And the time I also don't know. So so what we do in fact want this one to work out time, because we don't need the final velocity and we don't have the final velocity. Okay. So we want an equation which doesn't have v in it, and that would be this one here. We're going to rearrange it for t, which would be quite tricky currently because we've got t and then t squared, so it's like a quadratic. But we don't have to worry too much about that because the ut is going to cancel out because we have a 0 value. Okay, for u. That makes sense? So in other words, it's going to be 5 meters is equal to 0. 0 times t is just 0, plus half times 9.81 times t squared. So we can, basically the 0 doesn't need to be really written. So we've got that. Often what you want to do, to be honest with you, is write 9.81 as g. So 5 meters is equal to half g, because g is the strength of gravity, t squared. So the next thing I'm going to do is I'm going to multiply both sides by 2. And so I've got 10 meters is equal to g t squared. Then I'm going to divide both sides by g. So I put the g over here and underline it. And then I'm going to square root it, and I square root both sides, and that's t. So we've got our value for t. Okay, to be honest with you, at this point, I'm not even going to put it into my calculator. I'm just going to leave it as 10 meters over g, all square rooted. Okay. All right. And so the next thing is, how far will the ball travel? So now I'm looking at the horizontal. Basically, one of the balls, which means how far will the ball travel? It means this one, right? That one's obviously not going to travel any distance at all. So, because horizontal motion is entirely independent of vertical motion, then you can it's going to travel a certain distance in the same period of time, because by the time it's fallen, it's not going to travel any further, and it's going to be traveling at 25 meters per second. So we could actually use the same formula. The distance is equal to ut. This is horizontally now, so I'll do an arrow to show horizontally, and earlier on I couldn't do an arrow to show vertically. Horizontally, s is equal to ut plus half at squared. Oh, hang on a second. So we can use the same formula. Obviously, it's going to, if I do half plus half at squared. Now, horizontally, there is no acceleration. If we assume there's no air resistance, which we do generally speaking in projectile motion questions. So because acceleration is going to be equal to 0, that second part of the equation is now the one that disappears. So s equals ut. Displacement is equal to the initial speed multiplied by the final multiplied by the time. So you can then say, well, that the initial speed was 25. We know the time is basically whatever this is, so it's going to be 25 multiplied by 10 over g. Okay, so let's put those into the or 10 meters over g. So let's tap those into a calculator and get a value for t and also a value for this the range, the how far it's going to go. Okay. So basically the time would be equal to pretty much 1 second, but 1.0096 seconds. And that's no surprise because g is roughly 10, and we're doing 10 divided by 10, and I'm square rooting it. So yeah, it's going to take about 1 second for both of them to fall. And it's the second one, the one that's being projected sideways, is going to travel that far. Okay.